Hello there, and welcome to Deep Space Sleep. I'm glad you're here tonight. Beneath every orbit, beneath the drifting dust of space and the quiet pull of gravity, there is something vast and gentle, a rhythm that never ends. It doesn't hurry. It doesn't speak. It simply moves, holding everything in place. Jupiter is that rhythm, the soft balance behind the solar system's storms. What we call a planet is more like a slow, cosmic heartbeat made of wind, light, and pressure. Science can measure its speed, its size, its storms that rage for centuries, yet the stillness inside it remains untouched. Tonight, we'll drift through that quiet giant, through its glowing clouds, through oceans of metallic hydrogen, through the storms that dream in silence and the auroras that whisper at its poles. We'll listen to what gravity sounds like when it becomes peace. Before we begin, let me know in the comments where you're listening from tonight and what time it is where you are. Your words help other sleepy souls find their way to this calm corner of the universe. For now, let your breath slow. Let your thoughts drift outward. Let's begin. Jupiter is a world of impossible scale, a sphere so vast that it could hold 11 Earths across its diameter and still have room to breathe. Seen from space, its presence dominates the solar system like a slow-moving sunrise, a storm of color and gravity woven together. The planet's edge curves so gently that it looks more like a horizon than a globe, and its spinning clouds stretch across a surface larger than all the continents of our world combined. From that distant edge of light, Jupiter watches over everything, steady and endless, turning once every 10 hours, while the rest of the cosmos moves around it in quiet awe. Its mass is 318 times greater than Earth's, and yet it floats with grace. A giant of gas and light balanced between pressure and emptiness. Inside its vast interior, hydrogen and helium drift like the breath of a sleeping sun, creating a gravity that shapes the orbits of worlds millions of miles away. Everything that circles the sun does so slightly differently because Jupiter exists. Its pull is gentle but constant, guiding asteroids, moons, and dust into an invisible rhythm that holds the solar system together. If you could peer inside the planet, you would find room for more than 1,300 Earths, each one floating like a pearl in an ocean of cloud. It is not solid, but a boundless mix of gas and liquid, a place where pressure replaces ground and storms spiral endlessly through layers of color. The deeper you go, the heavier the air becomes, until molecules press so tightly that they begin to glow from within, turning the atmosphere into a soft furnace that radiates more heat than it receives from the sun. Far from our small world, Jupiter orbits the Sun at a distance of 778 million kilometers, to a journey so far that sunlight there takes 43 minutes to arrive. From that reach of darkness, the planet drifts like a lantern, reflecting light faintly back toward us. Space around it hums with charged particles, drawn by the power of its magnetic field. Its gravity curves the paths of comets and asteroids, turning Ks into pattern. If not for Jupiter's watchful presence, Earth itself might face a very different sky. A single year on Jupiter lasts almost 12 of ours. Time there moves slowly, stretched by distance and scale, while generations rise and fall on Earth. A single season might pass within its clouds. The Sun, seen from Jupiter, is a distant spark, yet still bright enough to cast pale shadows across its upper storms. In the deep quiet of space, Jupiter keeps turning a timeless guardian, measuring the years not by days or months, but by orbits that hum like cosmic breathing. Jupiter leans only 3 degrees on its axis, which means it barely knows the idea of seasons. While Earth tilts and breathes through cycles of summer and winter, Jupiter remains steady, its poles glowing under constant twilight. This gentle alignment keeps its weather predictable in rhythm yet chaotic in motion. With storms that rise and fall without the pull of changing sunlight, clouds flow endlessly across latitudes that never truly warm or cool, painted in eternal bands of amber and cream. In this still geometry, the planet seems to sleep with its eyes open, turning forever beneath the calm weight of the sun. A single day on Jupiter lasts only 10 hours, the fastest rotation of any planet in the solar system. Its immense body spins so quickly that the clouds stretch into streaks, forming belts and zones that circle its waist like ribbons of air. This rapid motion flattens the planet slightly, widening its equator by thousands of kilometers. Deep inside, the spinning pressure stirs metallic hydrogen, generating the magnetic field that hums around it. Each turn sends waves of energy rippling outward into space, as if the planet's heartbeat could be heard across the void. It is a storm wrapped around silence, a motion too vast to ever stop. Jupiter is so heavy that the balance point between it and the Sun, called the barycenter, lies outside the Sun's surface. It is as if the two bodies dance around an invisible point in space, a gravitational duet where even the star must sway every 8 days. The Sun itself moves slightly because of Jupiter's pull, tilting the entire solar system by a fraction of a degree. This delicate balance shows how mass shapes motion, how one planet's presence can make a star shift in its seat from the outer darkness. This motion looks like a heartbeat between light and shadow, the silent rhythm of cosmic partnership. Almost all the remaining mass of the solar system after the Sun belongs to Jupiter. It is the anchor that keeps the planets in line, the second great weight after the burning core of the system. If the Sun is the flame, Jupiter is the stone that holds the flame still. Its bulk contains more than twice the matter of all the other planets combined, pulling them gently into stable paths. Even Saturn, massive and ringed, follows the pattern Jupiter sets. Together they weave harmony through gravity alone, a balance that keeps the solar system from collapsing into chaos. The gravity of Jupiter is 2.5 times stronger than Earth's. Near its clouds, everything falls faster, every atom pulled inward with unstoppable force. This power bends light, curves space, and catches asteroids that wander too close. Many of the comets that might have struck Earth are drawn instead into Jupiter's embrace, destroyed in flashes of fire that protect the inner worlds. Its pull is fierce yet protective, a guardian's strength hidden inside the quiet face of storms. To float above its clouds would be to feel the weight of eternity pressing down the calm power that holds the solar system together. But beneath its size, there's a quiet balance that holds our solar family together. The clouds that cover Jupiter are only about 50 kilometers deep, yet they hide an entire world beneath them. Thin by planetary standards, they drift like silk stretched over an ocean of gas and pressure. Sunlight strikes the upper layers and reflects outward, giving the planet its familiar glow. These clouds are built from ammonia crystals, each one reflecting light in delicate patterns that shimmer and fade as the winds shift. Even with their modest depth, they form the planet's visible face, the part that telescopes and cameras see an ever-changing canvas of storm and calm. Beneath them, The pressure rises quickly, turning air into liquid, and what begins as color and light becomes weight and silence. Most of Jupiter's atmosphere is made of hydrogen and helium, the same ingredients as the Sun. It is a planet that almost became a star, but stopped just short of ignition. Its air is lighter than any gas we know on Earth. Yet, under enormous pressure, it flows like a slow ocean. Hydrogen drifts upward, while helium pools deeper below, mixing in turbulent layers that shift constantly. Lightning flickers inside these layers, releasing bursts of energy that glow faintly through the haze. In this mixture of invisible elements, the planet's storms are born great spirals of gas, driven by heat from within, turning physics into art. The colors of Jupiter's clouds come from mysterious compounds known as chromophores, pigments that paint the sky without ever solidifying. Scientists still don't know their full composition, but they are thought to be made of sulfur, phosphorus, and complex organic molecules formed under high pressure. These chromophores absorb sunlight differently at each altitude, creating streaks of cream, bronze, and crimson that shift as the atmosphere churns. Every hue is alive, constantly remade by chemistry and wind. If you could drift through them, the colors would blur and reform around you, like being inside a living painting that never stops breathing. When ultraviolet light from the sun touches Jupiter's upper atmosphere, it breaks apart the chromophores, scattering fragments that combine again in new ways. This slow process creates the planet's iconic red, yellow, and brown bands. The light reacts with ammonia and sulfur, forming tiny particles that catch and bend sunlight differently across latitudes. The result is a planet wrapped in glowing ribbons, each one born from invisible chemical dances. As the light fades toward twilight, those same bands turn soft gold and rose, making the gas giant look almost gentle, a world of storms wrapped in the colors of dawn. Across Jupiter's face, the cloud belts divide cleanly by latitude, each line stable and distinct for centuries. Some flow eastward, others westward, their boundaries defined by jet streams stronger than anything on Earth. The repetition is hypnotic, light and dark, high and low, updraft and downdraft, all moving in endless counterpoint. These patterns never stay still, yet they never lose their order. As if the planet breathes in rhythm with time itself, observers over generations have watched these same bands drift, twist, and return, a silent ballet of color and motion that has endured longer than human memory. The bright zones of Jupiter are regions of cool, rising gas, high enough for ammonia crystals to freeze and scatter sunlight into pale shades of white and gold. These zones climb higher than the surrounding clouds, forming ridges of brightness that drift slowly across the planet's surface. Beneath them, cooler temperatures cause gases to expand, lifting vast sheets of atmosphere upward, like waves frozen in time. When sunlight hits them at just the right angle, their edges glow softly, giving Jupiter its luminous texture. Each zone is a gentle crest in an endless ocean of air, rising in silence, while deeper layers churn far below. To the eye, they appear still but within their light. Countless storms breathe, form, and fade away. Between those shining zones lie the dark belts, where warm gas sinks back toward the depths. Here, the colors turn bronze and crimson, shaped by heat and chemical reaction. These belts are valleys between the bright ridges, deeper, denser, and far more violent. They pulse with hidden lightning and immense convection currents that twist like rivers in motion. The sinking air compresses, creating heat that darkens the clouds. Ammonia turns to vapor, and deeper compounds rise to stain the air in ochre and brown. Looking down from orbit, each belt seems to pulse, breathing in slow rhythm with the planet itself, a heartbeat of descending wind and returning calm. The winds that shape Jupiter's belts and zones do not flow together. They oppose one another, carving the sky into alternating bands of eastward and westward motion. Each jet stream can stretch thousands of kilometers wide, spinning in opposite directions with fierce precision. At their boundaries, turbulence forms like lace, curling and weaving into small storms that flicker with energy. This alternating pattern stabilizes the planet's atmosphere, creating order within chaos. Seen from above, these counter-moving winds form a subtle vibration across the surface, a natural harmony that prevents total disorder. Every current pushes against its twin, and through that opposition, the entire planet finds balance, a lesson written in clouds. The winds themselves can reach astonishing speeds, sometimes as high as 540 kilometers per hour, yet they move in silence, unfelt by any ground, for there is no solid surface to resist them. They sweep through the upper atmosphere like music through air, endless and invisible. Each gust carries ammonia, ice, and faint dust from distant layers, feeding the motion that defines the planet's stripes. In these winds, color becomes movement. White turns gold, gold fades to rust, and rust dissolves into shadow. Even the great storms depend on this breath, drawing strength from currents older than civilization. Jupiter's entire face is weather, a canvas painted by wind alone. From afar, Jupiter looks like a giant painting made of water and light. Its clouds swirl in endless spirals, merging and stretching as though brushed by an unseen hand. No line is permanent. No color stands still. The whole world moves like liquid captured in motion. Through telescopes, the planet appears alive, shifting from hour to hour, revealing storms that rise and vanish like thoughts. Every rotation brings a new arrangement of form and hue, patterns born from the dance of heat, light, and gravity. What you see is not static matter, but flowing time itself. Among these flowing colors lies a single storm that has outlived empires. The storm known as the Great Red Spot has been watched since the 17th century, longer than any weather system in human history. When early astronomers first saw it through small telescopes, they thought it might be a shadow or a trick of the lens. But night after night it remained, turning with the planet like a scar upon its clouds. Over 4 centuries later, it is still there, vast, swirling, and unbroken. Generations have come and gone, yet this storm endures, older than nations, older than machines, moving to a rhythm beyond comprehension. It has become Jupiter's heartbeat, pulsing quietly in the endless wind. No one knows when it began, or when it might fade, only that it has outlived every observer who ever looked upon it. Inside the Great Red Spot lies enough space to fit the entire Earth. Its oval shape stretches more than 16,000 kilometers across, a world-sized whirlpool of air that never rests. The storm's outer edges move in opposite directions, twisting the center into a continuous spiral that rises and sinks with violent grace. Clouds at its rim tower over one another, while the heart of the storm dips downward into a deep basin of churning gas. Seen from above, it looks serene, a soft red eye turning slowly but inside. Winds roar and collide in a chaos of unimaginable power. It is the largest, oldest hurricane in the solar system, a monument carved in motion. The Great Red Spot towers 8 kilometers higher than the surrounding clouds, its top layer reaching into sunlight, while the edges cast vast shadows on the belts below. These upper peaks are cold and thin, sculpted by wind that has blown without pause for centuries. From that height, you could look down into rolling valleys of cloud, glowing amber and white, stretching far beyond the horizon. Lightning flashes deep beneath the haze, like silent veins of fire. As the sun moves across the planet, its light grazes the storm's crest, igniting its color for a few brief hours before fading again into dusk. The storm rises and falls with Jupiter's day, a living mountain of gas. The deep crimson color of the Great Red Spot is born from sunlight itself, high in the storm's clouds. Ultraviolet radiation reacts with chemicals like ammonium hydrosulfide, breaking and reshaping them into compounds that reflect red and orange light. Over time, these pigments sink and mix, giving the storm its layered, rusted tones. The color changes subtly from year to year, sometimes bright like copper, sometimes pale like fading clay. Depending on the height of its haze, it is a living palette of chemistry and light, where every gust rewrites the sky. Scientists believe that without sunlight, the storm would fade to white, proof that even on Jupiter, color depends on light's fragile touch. Within the storm, winds reach speeds of 430 kilometers per hour, strong enough to shred any craft that dared to enter. Yet in the thin air of Jupiter's upper atmosphere, this speed carries no sound, no thunder, only endless motion. Clouds move in great arcs, blending red, gold, and cream into ribbons that twist like smoke in water. Pressure changes constantly as warm air rises and cold gas sinks, feeding the storm's rotation with quiet persistence. Despite the violence of its motion, the Great Red Spot remains strangely stable, anchored by the very forces that should destroy it. To watch it spin is to see balance born from chaos, a perfect storm that has learned how to last forever. Over the past century, the Great Red Spot has been slowly shrinking, its once vast oval tightening into a smaller, faster vortex. When early space probes first captured close images, the storm measured over 40,000 kilometers across. Today, it spans barely half that width. Yet, as it contracts, its color deepens and its rotation quickens, like a heartbeat accelerating with age. Scientists believe surrounding jet streams may be stealing its energy, folding smaller eddies into its rim and altering its shape. To the human eye, it is still enormous, still powerful, but its edges are fading, a quiet reminder that even something that has endured for centuries is not immune to time. Someday, perhaps in our lifetimes or perhaps far beyond them, the red eye of Jupiter may finally blink shut, and the planet's clouds will flow unbroken once again. In the year 2000, astronomers witnessed the birth of a new storm, smaller, but strikingly similar, nicknamed Red Spot Jr. It formed when 3 white ovals, each their own self-contained cyclone, merged in the planet's southern hemisphere. For months they swirled together like dancers in slow motion, until one fast vortex emerged, glowing faintly pink against the pale clouds. Over time, sunlight darkened it to a copper hue, echoing the larger storm that towered above it. Though much younger and smaller, Red Spot Jr. carries the same relentless energy, spinning for decades in defiance of Jupiter's chaotic winds. The sight of two crimson eyes gazing from the planet's surface was haunting, as though Jupiter itself had awakened to watch the universe. Elsewhere across the planet, storms bloom and fade with unimaginable lifespans. Some last a few weeks, others centuries. These tempests rise from the lower atmosphere, fueled by heat and rotation, forming ovals of white or tan that drift in long, circular paths. In Jupiter's eternal twilight, they seem motionless, yet each one moves faster than any hurricane on Earth. The oldest storms leave subtle scars in the atmosphere, ghostly rings where clouds once churned. Even as they dissolve, their patterns return in new places, reborn from the same hidden forces. On Jupiter, no storm truly dies. It simply becomes part of the rhythm, a memory carried forward by wind. Though Jupiter's storms shift constantly, the Great Red Spot has never wandered far from its latitude. It circles the planet endlessly, bound to a narrow band between the belts and zones. Guided by the surrounding jet streams that hold it in place, here, air flows in opposite directions, creating a natural cradle that locks the storm's position. From a distance, it seems to drift across the planet, but in truth, it remains fixed within this invisible current. As the planet turns, the storm appears again and again, loyal to the same stripe of atmosphere for centuries. The precision of its path reveals the hidden architecture of Jupiter's wind's invisible walls that shape chaos into perfect order. In a single Jupiter day, which lasts only 10 hours, the Great Red Spot completes 3 full spins around its own center. Within those rotations, towering clouds rise and collapse. Lightning crackles unseen, and heat radiates from depths no probe has ever reached. The storm's rotation is constant, faster at the edge, slower near the core, giving it the illusion of breathing. If you could hover above it, you would see concentric rings of color rolling past each other, deep reds near the heart, pale golds at the rim. Each rotation carries fragments of older storms, traces of the planet's history woven into its motion. It spins not in rage, but in rhythm, like the slow turning of time itself. But even storms fade when we look deeper. Far below the clouds lies a glowing mystery. The outermost layer of Jupiter is made entirely of hydrogen gas, stretching thousands of kilometers deep before blending into the unseen layers below. This vast atmosphere has no surface, only a gradual thickening of air until it becomes more liquid than gas. Here, molecules drift freely, forming endless waves that move like ocean currents across invisible depths. Sunlight barely penetrates the upper haze, scattering into faint gold before vanishing. Within this shimmering sea of gas, lightning dances silently, and waves of pressure ripple through the atmosphere, shaping storms above. The boundary between sky and substance blurs completely, so that no one could ever stand or fall there. The outer layer is both atmosphere and ocean, the veil that hides everything beneath. It is the planet's skin, thin in distance, but infinite in presence. Deeper inside Jupiter, the pressure grows so immense that hydrogen, the lightest element in the universe, begins to change its nature. gas compresses until it behaves like a liquid, flowing without resistance under gravity's command. In this layer, temperature and density rise together, creating an endless sea of shimmering fluid that reflects heat rather than light. The currents here drift slowly, turning the planet's energy outward, feeding the atmosphere above with warmth. This strange ocean has no waves or surface, only constant motion, a slow heartbeat pulsing in silence. It is an ocean of something between air and metal, vast enough to drown whole worlds, yet perfectly calm, perfectly timeless, still deeper. Hydrogen becomes something far stranger, metallic hydrogen, a form so dense and pressurized that it conducts electricity like copper. This layer may be responsible for Jupiter's immense magnetic field, a structure large enough to stretch beyond Saturn's orbit. Inside this metallic ocean, atoms are crushed together so tightly that they lose their individuality, forming a sea of electrons that flow freely. Scientists believe the planet's magnetic hum begins here, deep below the clouds where light cannot reach. If you could hear it, it would sound like a slow vibration echoing through metal. Every storm, every flash of aurora, every spark of energy on the surface above is born from this metallic heart, glowing unseen in the dark. At the very core of Jupiter lies something mysterious, a region that may be made of ice, rock, and molten metals blended under unimaginable pressure. Some models suggest a solid core the size of Earth. Others think it has dissolved into a deep slurry of elements. Either way, this center burns with heat older than the solar system itself, the remnant of the planet's birth. It is where gravity's pull and pressure's crush meet in perfect balance, forming a heart of dense silence. This core radiates energy upward, keeping Jupiter warmer than sunlight alone could explain. Deep in that ancient furnace, time itself feels slower, every atom pressed into stillness, waiting for release. The pressure at Jupiter's core is 2 million times greater than the pressure at Earth's surface. To imagine, it is to imagine mountains collapsing into dust and oceans reduced to crystal. Under such force, molecules cannot exist. As we know them, they fuse, separate, and realign in strange new states of matter. Even light behaves differently. Bending under the crush of gravity and heat, this unimaginable compression is what holds the planet together, what allows it to shine faintly from within. No machine or probe could survive this world. It is a place of constant creation, where matter itself forgets its boundaries and becomes pure energy locked in stillness. Beneath the beauty of Jupiter's clouds lies a depth that defies both time and imagination. At the center of Jupiter, temperatures may rise to 24,000 degrees Celsius, hotter than the surface of some stars. This heat is born not from fusion but from pressure, a slow and endless squeezing of matter that keeps the planet glowing from within. In that deep furnace, hydrogen behaves like metal, releasing waves of energy that drift upward through layers of gas. If you could peer into this core, it would shine faintly red, a hidden ember burning at the heart of a frozen world. Every gust of wind, every flicker of lightning above, carries a trace of that ancient warmth. It is a sun that never ignited, forever trapped inside itself, keeping the giant alive through sheer compression and time. Jupiter radiates more energy into space than it receives from the sun, even from hundreds of millions of kilometers away. This hidden warmth gives the planet a quiet inner glow, The source of that energy lies deep inside the lingering heat of its formation and the constant pressure that squeezes it tighter with each passing century. This slow release of energy powers the storms that swirl endlessly above its clouds, while sunlight paints its surface in gold and amber. The true light of Jupiter comes from within, escaping in waves too long for human eyes to see. It is the faint heartbeat of a world that never cools. That heat comes from Jupiter's slow, steady contraction, a process known as Kelvin-Helmholtz heating. Over billions of years, the planet has been shrinking ever so slightly, converting gravitational energy into warmth. Each passing millennium, Jupiter grows smaller by a few millimeters, but with every contraction, it releases the heat that fuels its atmosphere. This quiet collapse is invisible to the eye, yet it powers the great storms and gentle winds alike. Deep inside, the gas giant is still settling, still adjusting to the weight of its own mass. The planet breathes not through air, but through pressure, exhaling warmth into the cold of space. The heat rising from within does more than illuminate, it paints. As the thermal energy rises, it stirs the clouds and alters their chemistry, changing Jupiter's colors from pale cream to ochre to crimson. Each band of atmosphere becomes a canvas shaped by light that never comes from the sun. The deeper the heat, the more vivid the tones above. Molécules réarrangent, pigments shift, and storms bloom like living brushstrokes across its surface. Through this constant motion, Jupiter renews itself, repainting its face over centuries in patterns that no two observers ever see the same way. The entire planet is a living portrait, brushed by warmth from below. If Jupiter had been only 75 times more massive, the pressure and temperature at its core would have ignited nuclear fusion, and it would have become a small star. The difference between a planet and a sun is a matter of scale, not essence. The same hydrogen, the same gravity, only more of it. Jupiter stands at the threshold of starlight, a failed sun that never quite began to burn, because it did not. Life on Earth could exist in balance, untouched by another blazing star. It remains forever between worlds too massive to be ordinary, too light to shine, holding within it the quiet potential of fire. And from that quiet heat, its invisible shield begins to glow. Jupiter's magnetic field is 14 times stronger than Earth's, a colossal force born from the deep ocean of metallic hydrogen turning far below its clouds. As the planet spins, that metallic layer behaves like a giant dynamo, generating electric currents that encircle the planet in invisible loops of power. This field is so vast and so strong that it can deflect the solar wind millions of kilometers away, wrapping Jupiter in a cocoon of charged particles near its poles. This magnetic power becomes light, bright auroras that never fade, glowing with steady brilliance while the rest of the solar system sleeps. The field hums in radio frequencies, a low song of electricity and motion, resonating through space like the slow heartbeat of a mechanical star. The magnetosphere of Jupiter extends nearly 3 million kilometers into space, so large that it could swallow the sun if it were visible from end to end. Within this invisible shield, radiation swirls and particles from the solar wind are trapped, spiraling endlessly along magnetic lines. These particles form belts of energy that stretch beyond the orbits of many moons, a vast magnetic ocean where light and matter drift together. To cross this region would be to sail through an unseen storm of electrons moving near the speed of light. This shield not only defines Jupiter's shape in space, but protects its moons, bending the solar wind into graceful arcs that shimmer faintly with energy. At Jupiter's pole, auroras blaze without pause, eternal curtains of light, brighter than anything seen on Earth. Unlike our northern and southern lights, which flicker and fade with solar storms, Jupiter's auroras never end. They pulse in ultraviolet and infrared light, invisible to the human eye, but brilliant in the instruments of telescopes. These lights are drawn out by the planet's immense magnetic field, constantly fed by charged particles crashing into its upper atmosphere. The glow outlines the shape of the magnetic poles, turning them into cosmic beacons. From orbit, the auroras appear like halos, softly turning in rhythm with Jupiter's spin, whispering energy into the void. The dancing lights of Jupiter's auroras are powered not only by the solar wind, but also by the restless moon Io, the most volcanic world in the solar system. Each eruption on Io throws clouds of sulfur and sodium into space, where Jupiter's magnetic field captures them and accelerates them along its lines of force. These charged particles rain down along the poles, lighting up the atmosphere in spirals of ultraviolet fire. The link between Jupiter and Io is like an electrical circuit on a planetary scale, one world feeding another through invisible threads of plasma. This connection makes Jupiter's auroras the most powerful in the solar system, glowing with a steady strength that humbles even the fiercest storms on Earth. Some of these magnetic currents extend beyond Io, reaching out to the other Galilean moons like luminous bridges of energy. Streams of particles travel along magnetic field lines, connecting Ganymede, Europa, and Callisto directly to Jupiter's poles. When these currents interact with the moon's surfaces, they create faint glows and flickers of radiation, a kind of cosmic dialogue written in light. Each moon responds differently, Ganymede with flashes of aurora of its own, Europa with subtle reflections beneath its icy crust, Callisto with a soft halo visible only in ultraviolet. These glowing pathways remind us that Jupiter is not one world but a system, each moon tied to its parent by magnetism, gravity, and light, an orchestra of energy in perfect silent balance. Surrounding Jupiter is a deadly radiation belt, far more powerful than the Van Allen belts that encircle Earth. Within this invisible ring, charged particles race through space at nearly the speed of light, trapped by the planet's immense magnetic field. The radiation here can melt electronics, destroy satellites, and corrode metal faster than acid. It's a vast ocean of invisible fire, humming with electrical energy strong enough to fry the systems of any unprotected spacecraft. When the Pioneer and Galileo probes passed through this zone, their instruments faltered, as if the planet itself were guarding its secrets. In this storm of radiation, Jupiter glows not just with beauty, but with danger, a place where energy reigns absolute. The intensity of Jupiter's radiation is so extreme that it would kill a human astronaut in just a few hours. The airless vacuum around the planet is saturated with energetic electrons and ions that pierce any known shielding. A dose here is not measured in days or months, but in minutes. Even robotic probes are built with layers of tungsten and titanium to survive brief exposure, their systems blinking beneath the onslaught like candles in a hurricane. This invisible storm makes Jupiter's surroundings some of the most hostile environments in the solar system, a glowing trap of pure energy, where life and machinery alike would vanish under its silent burn. Among Jupiter's moons, Io suffers the worst of this radiation. Orbiting deep within the heart of the planet's magnetosphere, it is bombarded with 3,600 rem of radiation every single day. For comparison, That's enough to kill a human within 4 hours. This constant punishment strips atoms from Io's surface, creating clouds of sulfur and oxygen that drift into space and feed Jupiter's auroras. Its landscape, already torn by volcanoes, is also scarred by radiation that changes the color of its rocks and gases. Io is a moon of fire and lightning, locked forever in Jupiter's magnetic storm, a glowing ember caught in the orbit of a giant. Jupiter's auroras are the brightest in the entire solar system, burning with power 1,000 times greater than Earth's northern lights. These magnificent displays are not limited to fleeting moments of solar activity. They are permanent, fueled by the planet's magnetic field and the constant bombardment of particles from the Sun and its own moons. In ultraviolet light, the auroras form glowing circles that ripple and pulse like living creatures. They shine so intensely that they can be seen from millions of kilometers away by telescopes orbiting Earth. Their light flickers across Jupiter's poles like silent storms of beauty and energy, a dance of creation and destruction happening every moment of every day. When seen in ultraviolet, Jupiter's auroras take on the shape of a luminous heart, a pulsing glow of light and energy at the top and bottom of the planet. To human eyes, they would be invisible, but in the right spectrum, they look like a living heartbeat made of fire. The currents that feed them rise from deep within Jupiter's metallic core, traveling outward through invisible magnetic veins before igniting the upper atmosphere in electric blue. It is as if the planet itself breathes light, exhaling a rhythm that connects its inner heat to the cold of space. Around this magnetic world, a family of moons orbits like frozen echoes of time. Jupiter is surrounded by a vast family of moons, at least 79 that we know of, each one tracing its slow, silent path through the planet's gravity. They range from tiny captured asteroids to worlds large enough to rival Mercury, locked in their orbits like glowing beads around a lantern. Most of them are ancient, fragments left from Jupiter's birth, but 4 of them stand apart. These are the Galilean moons, discovered more than 4 centuries ago, when humanity first realized that not everything in the heavens revolved around Earth. They orbit together like a miniature solar system, ruled by Jupiter's immense pull and bound to its magnetic glow. In 1610, Galileo Galilei turned his handmade telescope toward the night sky and saw something that would change history forever. 4 bright points moved alongside Jupiter, night after night, tiny wandering stars that revealed themselves to be moons. They were later named Io, Europa, Ganymede, and Callisto. These 4 moons became symbols of a larger truth, that the universe was not centered around us. Today, they remain among the most studied bodies in the solar system, each one unique, each one holding secrets of formation, magnetism, and life beneath ice. Io, the innermost of the 4, is unlike any other moon in existence. Its surface is a landscape of fire, hundreds of volcanoes constantly reshaping the crust, fountains of molten rock rising into the blackness of space. Io is the only known moon with active volcanism, and its eruptions paint the surface in vivid yellows, reds, and whites made from sulfur compounds. The constant bombardment of Jupiter's radiation gives its poles a burnt, crimson hue. Through every telescope, Io glows like an ember caught in the cold. It is a world forever changing, consumed and reborn by its own volcanic heart. All of Io's fury comes from the invisible forces holding it. As the moon orbits close to Jupiter, it is pulled and stretched by the planet's gravity. The other Galilean moons, Europa and Ganymede, tug at Io as well, keeping its orbit slightly elliptical. This constant squeezing and relaxing creates immense friction inside, heating the moon from within. The process is called tidal heating, and it turns gravity itself into fire. Beneath Io's crust, silicate rock melts into magma, feeding vast lava lakes that bubble through its plains. The heat never stops. It is the eternal rhythm of orbit and pull, the dance between moon and giant. When Io erupts, it does so on a scale that defies imagination. Some volcanic plumes rise 300 kilometers high, 30 times taller than Mount Everest. These eruptions release sulfur and oxygen into space, forming a torus of glowing plasma that encircles Jupiter like a ring of light. The particles from these plumes feed the planet's auroras, connecting moon and world in a circuit of pure energy. The volcanoes themselves leave vast rings and plains of frozen sulfur, coloring Io in shades of gold and rust, even from millions of kilometers away. Probes like Voyager and Juno have captured these towering fountains of fire, silent, majestic explosions lighting the edge of Jupiter's shadow. Europa drifts farther out from Jupiter, silent and gleaming like a frozen pearl. Beneath its bright surface lies something extraordinary, a global ocean of liquid water, twice as deep as all of Earth's seas combined. Its crust of ice, perhaps 20 kilometers thick, floats on a hidden sea kept warm by tidal forces and the slow churn of a rocky mantle below. This ocean could contain more water than any world we know. And where there is water, there may be life. Scientists believe chemical reactions between rock and water at the ocean floor could create heat and minerals. The same recipe that feeds life on Earth's deep seafloor. Europa's smooth, unscarred surface hides cracks and ridges where that inner ocean pushes upward, whispering that beneath the silence, something still moves and breathes. Though Europa's days are bright with sunlight reflected from its icy crust, its nights may shimmer faintly with their own ghostly glow. Jupiter's powerful radiation bombards the surface, causing molecules in the ice to release flashes of light, a soft luminescence visible only to those who could stand in its darkness. Scientists call this radioluminescence, and it may bathe Europa's frozen plains in pale green or blue light. It is an eerie, beautiful image, a world glowing from within as invisible energy passes through it. The same radiation that makes Europa so dangerous may also make it beautiful, turning the cold silence of night into a quiet aurora spread across ice. Farther out, Ganymede reigns as the largest moon in the solar system, even bigger than Mercury. Beneath its crust of ice and rock lies a vast ocean, and deep within that ocean, a metallic core spins, slowly generating a magnetic field all its own. Ganymede is the only moon known to have such a field, and it gives rise to faint auroras that dance near its poles, glowing in Jupiter's shadow. Its surface tells the story of time itself, dark, ancient regions heavy with craters, and younger, brighter plains carved by tectonic stress. It is half ice, half rock, and entirely mysterious, a world of gravity, magnetism, and frozen storms circling its giant parent in endless silence. Then comes Callisto, the outermost and oldest of the Galilean moons, a relic from the dawn of the solar system. Its surface has remained unchanged for 4 billion years, covered in craters, stacked upon craters, every scar a memory of an ancient impact. Unlike the restless worlds closer to Jupiter, Callisto is quiet, geologically dead, and untouched by tidal heating. Beneath its thick crust may still lie a layer of liquid water, but above, nothing moves. The land is flat, cold, and ancient. It is a museum of time, a world that has watched creation unfold without ever changing itself. Callisto is the still face of eternity, reflecting sunlight as softly as an old stone beneath the stars. Each of Jupiter's great moons is a world unto itself: volcanic fire, frozen ocean, magnetic storm, and ancient silence. Together, they orbit like a family bound by invisible threads of gravity and light, each one playing a part in the great music of Jupiter's realm. Through telescopes and passing probes, we glimpse them as bright dots around a glowing planet, but each holds the complexity of a living world: mountains, storms, oceans, and mystery. Their dance around Jupiter is timeless, a quiet ballet in the outer dark, and sometimes these moons sing back through radiation, ice, and light. In 1994, the world watched as comet Shoemaker-Levy 9 met its end in Jupiter's embrace. The fragments of the comet, broken apart by the planet's tidal forces, plunged into the giant's atmosphere one by one over 6 long days. Each impact sent shock waves rippling across the cloud tops, plumes of fire rising thousands of kilometers into the air. From Earth, telescopes caught the flashes, brilliant scars of light marking the violence of the collision. For the first time, humanity witnessed a planetary impact in real time, a reminder of how fragile and dynamic our solar system can be. In that moment, Jupiter became both destroyer and guardian, taking the blow that might otherwise have fallen closer to home. The impact of Shoemaker-Levy 9 unleashed energy equal to 300 million atomic bombs. Each explosion tore open Jupiter's upper atmosphere, creating fiery scars that glowed for weeks. The heat and pressure from the collision reached unimaginable levels, churning hydrogen and helium into vast waves of turbulence that spread for thousands of kilometers. Scientists around the world observed with awe, measuring the brightness, timing, and chemical aftermath of every strike. For a brief time, Jupiter became the stage for the most powerful natural explosion humanity had ever seen. It was a celestial warning written in flame-proof of how immense forces still shape our skies. At the moment of impact, temperatures soared to 30,000 degrees Celsius, hotter than the surface of the Sun. In the thin upper layers of Jupiter's atmosphere, gases ignited in brilliant flashes that lasted only seconds before fading into long columns of ash and vapor. These plumes rose 3,000 kilometers high before falling back, forming dark rings of soot. The light from the explosion crossed nearly 800 million kilometers of space, reaching Earth as faint blinks of energy caught by orbiting satellites. The planet absorbed it all silently, its clouds rippling and glowing from within, as if exhaling the remnants of a cosmic fire. Among the many fragments of Shoemaker-Levy 9, one stood out, a massive piece, nearly 2 kilometers wide, roughly the size of a large island on Earth. When it struck Jupiter, the resulting shock wave circled the planet in minutes, echoing through its vast gaseous layers. This fragment's impact left a bright flare visible from Earth with amateur telescopes, followed by a spreading bruise across the planet's southern hemisphere. Scientists calculated that such an impact occurs once every 6,000 years, a rare reminder of how Jupiter's enormous gravity draws danger away from the inner planets. In its destruction, the comet revealed the quiet heroism of the giant that guards us, The scars left by Shoemaker Levy 9 darkened into stormy blotches larger than the entire Earth. These marks remained visible for months, drifting with Jupiter's turbulent jet streams. Through them, astronomers traced how shock waves moved through the planet's atmosphere, revealing hidden layers and currents unseen before. The collisions opened windows into Jupiter's chemistry, exposing elements like sulfur and carbon compounds rising from the depths. It was as if the planet briefly revealed its inner anatomy through pain. Those dark scars slowly faded, but the memory of them remains proof that even the mightiest worlds can be wounded, and that Jupiter, the great protector, quietly stands between our fragile world and the chaos beyond. When the first fragments of the comet struck, the Galileo spacecraft, still en route to Jupiter, captured what no human had ever seen before. It recorded the initial fireballs erupting from the planet's atmosphere, vast plumes of gas and vapor stretching higher than Mount Everest 30 times over. Each burst flared in infrared, blazing with more heat than the sun's surface, before curling into dark bruises of soot and dust. Galileo's instruments measured their expansion, revealing how shock waves rippled through Jupiter's dense clouds. It was the first direct observation of a cosmic collision shaping a planet in real time, a moment where human technology and celestial violence met in silent harmony across the void. While Galileo provided the first glimpse, the Hubble Space Telescope became our long-distance witness from its orbit above Earth. Hubble watched the aftermath unfold for months, capturing the spreading clouds of debris drifting across Jupiter's upper atmosphere. The dark scars stretched wider than Earth, their shapes twisting and fading with the planet's fierce winds. Hubble's ultraviolet and visible light images showed how the dust absorbed sunlight and how the gases beneath swirled in luminous rings. Those haunting marks became a cosmic reminder of motion and impermanence, storms born from destruction, still glowing long after the impact faded from sight. The Shoemaker-Levy 9 collision gave scientists an unexpected gift, a direct look into Jupiter's hidden layers. As the comet's fragments plunged through the atmosphere, they acted like probes, stirring the gases and revealing what lay beneath the thick cloud tops. Spectrographic data showed compounds of sulfur, carbon disulfide, and even traces of water, materials brought up from depths never before observed. These findings reshaped our understanding of how Jupiter's atmosphere behaves, proving that beneath its beauty lies a restless, dynamic world. The impact became more than an event. It was an accidental experiment, helping humanity peer into the heart of a giant without ever touching its surface. Jupiter's powerful gravity does not just draw in the occasional comet, it has been capturing and consuming celestial wanderers for billions of years. Astronomers estimate that every 1,000 years, the planet pulls in thousands of comets and asteroids that might otherwise cross Earth's path. Many are vaporized in its dense atmosphere before ever reaching the clouds below. Others are deflected outward, slingshotted into deep space by Jupiter's immense pull. Its gravitational presence shapes the orbits of countless objects, sculpting the architecture of our solar system like an unseen guardian. Every fiery impact upon its surface is a silent sacrifice, sparing the inner worlds from chaos. Because of Jupiter, Earth may have survived long enough for life to flourish. Without its massive gravity acting as a cosmic shield, the frequency of catastrophic asteroid strikes on our planet could have been far higher. Many scientists believe that Jupiter's quiet vigilance has prevented multiple mass extinctions by diverting or absorbing the very bodies that could have ended evolution's delicate balance. It is both protector and participant, a colossal presence ensuring the survival of fragile worlds orbiting closer to the Sun. Each time a comet vanishes into its storms, it renews the silent pact that allows life here to continue breathing beneath our gentler skies. And while it shields us, it also teaches us how fragile our own world truly is. In 1973, Pioneer 10 became the first human-made object to reach Jupiter, crossing the vast gulf of space after a journey of 600 million kilometers. As it approached, the spacecraft endured intense radiation and powerful magnetic fields, its systems flickering under the strain. Yet it succeeded, sending back the first close-up images of the gas giant, a blurred but breathtaking view of swirling clouds and turbulent storms. Pioneer 10's instruments measured Jupiter's immense magnetic field and discovered how its radiation belts extended far beyond what scientists had imagined. It was humanity's first handshake with a world of titanic forces, a silent passing between a fragile machine and the largest planet in the solar system. Just a few years later, Voyager 1 and Voyager 2 followed, capturing images that would forever change our understanding of Jupiter. Their cameras revealed the Great Red Spot in unprecedented detail, a storm large enough to engulf Earth. Spinning in mesmerizing shades of amber and cream, they showed us volcanic eruptions on Io, icy ridges on Europa, and lightning within Jupiter's deep clouds. The Voyagers taught us that this world was not static, but alive with motion, chemistry, and light. Every frame they sent home was a postcard from the edge of gravity, a glimpse into a planet both violent and magnificent. In 1989, NASA launched Galileo, the first spacecraft ever to orbit Jupiter. It arrived in 1995 after a 6-year voyage, entering the planet's magnetic realm like a ship sailing into a cosmic storm. Galileo's long mission transformed our knowledge of Jupiter's moons, revealing Io's molten lakes, Europa's hidden oceanen, and Ganymede's magnetic field. Its orbit took it repeatedly through Jupiter's radiation belts, where it endured doses strong enough to destroy any unprotected electronics. Galileo was not just a probe, but a survivor, a witness to beauty and destruction, sending back data that would shape every mission that followed. Galileo also carried a small descent probe, a metal capsule built to dive directly into Jupiter's atmosphere. In 1995, it entered at 200 kilometers per second, faster than any object in history. The probe endured crushing heat and pressure, parachuting through clouds of ammonia and hydrogen for 58 minutes before losing contact. In that short time, it measured winds of 500 kilometers per hour, detected lightning, and revealed that Jupiter's atmosphere was drier than scientists expected. It was humanity's first and only direct touch with the planet's sky, a descent into the heart of a storm that no human eye could ever see and survive. Decades later, Juno arrived to continue the story. Launched in 2011 and entering orbit in 2016, it became the first spacecraft to circle Jupiter's poles, capturing breathtaking views of swirling cyclones and glowing auroras unseen from Earth. Its instruments peered deep into the planet's clouds, mapping magnetic fields and gravity with unprecedented precision. Juno revealed that Jupiter's core may be diffuse, its storms far deeper than imagined, and its auroras powered by electrical currents from its moons. As it continues its mission today, Juno glides above the giant's marbled surface like a watchful eye, a quiet observer chronicling the poetry of gas, light, and motion. From its polar orbit, Juno captured the first ever images of Jupiter's North Pole, a world no telescope on Earth had ever seen. Instead of the familiar horizontal bands, it revealed a chaotic mosaic of swirling storms, each thousands of kilometers wide, arranged in perfect geometric clusters. The cyclones moved in slow spirals of turquoise, white, and gold, creating a pattern that looked more like living art than weather. These images transformed our understanding of the planet's atmosphere, showing that Jupiter's poles were not symmetrical or uniform, but alive with constant, turbulent motion. Through Juno's lens, the giant became something new, not just a planet, but a churning masterpiece of fluid beauty and cosmic balance. Among Juno's most astonishing findings was the discovery that Jupiter's magnetic field is not symmetrical as once thought. It is twisted and uneven, with one hemisphere far stronger than the other. Scientists named the strongest region the Great Blue Spot, a magnetic storm unlike anything in the solar system. This asymmetry suggests that Jupiter's magnetic dynamo deep within its metallic hydrogen layer behaves in complex and shifting ways. The field itself seems to drift and evolve, a living magnetic ocean flowing beneath the clouds. Through Juno, we learn that Jupiter's magnetism is not a fixed force, but a restless energy that pulses and moves with time. As Juno's instruments peered deeper into Jupiter's interior, they detected far more heat than models had predicted. The planet seemed to glow from within, releasing energy generated by the slow contraction of its vast body and the mixing of hydrogen deep below. This hidden warmth drives the constant renewal of its clouds and storms, giving the planet its luminous appearance. The findings suggest that Jupiter is still cooling from its formation 4.5 billion years ago, its heart radiating like a fading ember of creation. Even now, the planet continues to change, its atmosphere reshaped by the invisible heat rising from its core, a quiet fire that never truly dies. When Juno passed directly over the Great Red Spot, it used microwave sensors to measure the storm's depth for the first time. The data revealed that the vortex extends more than 350 kilometers below the cloud tops, deeper than any hurricane on Earth by far. Within that depth, winds swirl at 400 kilometers per hour, rotating endlessly for centuries. The discovery showed that the red spot is not a surface storm, but a colossal atmospheric column anchored deep in Jupiter's fluid layers. Beneath its familiar red hue lies a complex engine of heat, chemistry, and motion, a storm so vast it touches multiple layers of the planet's hidden world. Juno's mission will not last forever, but its legacy continues. 2 new explorers are already on their way: ESA's JUICE, the Jupiter Icy Moons Explorer, and NASA's Europa Clipper. Both missions will study the Galilean moons, searching for subsurface oceans, chemical reactions, and signs of life beneath the ice. JUICE will focus on Ganymede, while Europa Clipper will make dozens of close passes around Europa. Together, they carry the torch lit by Pioneer, Voyager, Galileo, and Juno, extending humanity's gaze farther into the Jovian system. Every mission brings us closer to a planet that still keeps most of its secrets. In the night sky, Jupiter is the brightest planet visible to the human eye, outshined only by the Moon and Venus. It glows with a steady, golden light that has guided astronomers for thousands of years. Even from more than 700 million kilometers away, its radiance pierces through the darkness, a constant beacon wandering among the stars. This brightness comes not from reflected sunlight alone, but also from the faint heat the planet emits from within. a soft glow born of its own energy. For ancient sky watchers, Jupiter was a symbol of protection and wisdom. For scientists, it remains a reminder that light can travel across vast silence, carrying both warmth and mystery from one world to another. At its brightest, Jupiter reaches a magnitude of -2.94, a number that marks it among the most luminous natural objects in the heavens. This brilliance makes it visible even through thin clouds, shimmering like a suspended lantern in the cosmic dark. When conditions are right, its glow appears almost alive, pulsing gently as atmospheric layers bend its light. Photographers and astronomers capture it through telescopes, revealing its faint disk and swirling belts. But even to the naked eye, its presence is unmistakable, a calm and steady light that seems to watch over the turning Earth each night. On clear evenings, Jupiter's light is so strong that it can cast shadows on Earth. Step into a quiet field under its glow, and you may see the outline of your hand faintly traced against the ground. Few other planets produce this effect. It is a measure of Jupiter's sheer brilliance, its ability to reflect the sun's rays like a distant mirror. The thought that a world so far away can touch ours with light is humbling. Each photon that reaches us has crossed the solar system, bouncing from clouds of ammonia and hydrogen before meeting the soil beneath our feet. In that faint shadow lies a connection between worlds delicate, silent, and real. Through infrared light, Jupiter reveals a different face, one invisible to human eyes. In this spectrum, the planet's heat glows softly, outlining its structure like a thermal map of the heavens. Instruments aboard telescopes and spacecraft capture these images, where dark bands mark cold regions thick with clouds, and bright areas show where heat escapes into space. The 4.68 micron wavelength, in particular, unveils a view of Jupiter as a living engine, its deepest layers shining faintly through the translucent haze above. In these images, Jupiter looks less like a planet and more like a star waiting to ignite. The 4.68 micron wavelength of infrared light has become one of the most revealing tools for studying Jupiter's atmosphere. It highlights where the cloud deck is thinnest, allowing heat from below to escape freely into space. In these glowing portraits, bright streaks of light mark windows into the planet's lower layers, while darker zones remain shrouded in cold, dense vapor. This technique helped scientists confirm that Jupiter emits more energy than it receives from the Sun, the slow release of heat from its core, still cooling after billions of years. To see the planet this way is to glimpse its inner fire, flickering quietly beneath a curtain of storms and gas, a hidden warmth that never fades. At Jupiter's North Pole, Juno discovered a breathtaking formation unlike anything seen elsewhere in the solar system. 9 massive cyclones arranged in a near-perfect square. Each storm is roughly the size of the continental United States, swirling in slow, silent motion around a single, larger vortex at the center. Their rotation forms a vast pattern of symmetry and chaos, a living mandala of clouds and wind. These polar storms remain stable year after year, locked in balance by the planet's Coriolis forces and deep heat rising from below. When viewed in infrared, they glow faintly, like coiling petals of red and gold around the pole. This strange harmony of power and geometry reveals Jupiter not as random turbulence, but as a masterpiece of fluid order, a calm, eternal dance within endless motion. In ultraviolet light, Jupiter's poles reveal even greater beauty. The planet's auroras, constantly alive, with charged particles from the solar wind and its volcanic moon Io, shift in brightness and shape every day. These ultraviolet observations show that the auroras pulse with Jupiter's rotation, flaring in arcs and curtains that rise and fade like cosmic tides. The light can surge without warning, glowing brighter when bursts of energy stream from Io's orbit or when the solar wind presses against the planet's magnetic shield. Through Hubble's ultraviolet vision, scientists have watched these auroras breathe, expanding and contracting as if Jupiter itself were alive, inhaling the sun's energy and exhaling it as light. Jupiter also sings in invisible frequencies. Its powerful magnetosphere generates bursts of radio waves and plasma signals called whistlers, soft chirping tones that ripple across space. These sounds are created when charged particles spiral along magnetic field lines, producing radio emissions that can be detected by spacecraft and even Earth-based antennas. To scientists, they are more than noise. They are the voice of Jupiter's magnetic ocean, translating invisible forces into sound. Each whistle, each hum, is a trace of energy flowing through the planet's vast magnetic fields, echoing like wind across an electric sea. Listening to them, one can almost hear Jupiter breathing through the fabric of space, though less famous than Saturn's. Jupiter also has its own delicate ring system, 4 faint bands encircling the planet like wisps of cosmic dust. These rings are nearly invisible in normal light, glowing softly only when illuminated from behind by the sun. They stretch outward for hundreds of thousands of kilometers, yet contain particles so small they would slip through a human hand. Discovered by the Voyager probes, they revealed a hidden grace to Jupiter's immense form, a reminder that even giants can have subtle edges. In the soft light of backscattered sunshine, these rings shimmer like threads of gold wrapped around a planet of storms. The faint rings of Jupiter are born not from shattered moons, but from the gentle dust that rises from smaller ones. Teeny meteor impacts strike moons like Amalthea, Thebe, and Metis, ejecting clouds of fine debris into space. Jupiter's gravity gathers this material into thin, persistent rings that orbit with quiet precision. The particles drift and collide, glowing faintly in scattered sunlight before falling back into the planet's pull. It is a constant cycle of creation and return, the moons feeding their parent, the planet shaping their dust into beauty. Beyond science, Jupiter becomes something else, a reminder of calm in infinite motion. In the myths of ancient Greece, Jupiter was known as Zeus, the ruler of gods, the keeper of thunder and order to early sky watchers. Its slow, bright movement across the heavens symbolized authority and protection, a cosmic reminder of balance within chaos. They saw in its steady light the pulse of a divine presence, unchanging amid the flicker of mortal stars. Even today, the name carries the same quiet gravity. Jupiter, the giant whose presence defines the rhythm of the solar system. It does not rage or boast. It simply holds the rest of the planets in place, its mass keeping them from drifting into the dark. In myth and in fact, it remains the same, the silent guardian of worlds. When the Romans gazed upward, they saw not Zeus, but Jupiter, Optimus Maximus, the greatest and the best, god of lightning and sky. The planet that bore his name reflected the same traits: power, radiance, and calm control over the celestial order. Every flash of lightning on its cloud tops, every storm swirling beneath its vast atmosphere, felt like an echo of divine energy. The connection between name and nature is uncanny. Both Jupiter the god and Jupiter the planet command through stillness, through presence alone. Each time its golden light rises in our night sky, it is as though the old myths awaken again, reminding humanity how small, yet how connected we are to the forces that shaped creation. Within Jupiter's magnetic realm, electric currents surge stronger than anywhere else in the solar system. These invisible rivers of plasma flow along magnetic field lines, linking the planet's poles to its moons in circuits of unimaginable power. The energy coursing through this system dwarfs anything created by humankind, generating bursts of radio waves and auroras brighter than 1,000 thunderstorms. This magnetic heartbeat never stops. It hums through space, reaching across millions of kilometers. The Romans called Jupiter the god of thunder, and in truth, the name fits perfectly. Its magnetic storms are the real thunder of the cosmos, a pulse of living electricity that keeps the solar system alive with motion and sound. Deep within its vast form, Jupiter continues to contract, ever so slowly, as it has for billions of years. This gentle shrinking releases heat, the same quiet energy that glows through its atmosphere and drives its storms. In a way, the planet is still cooling from its birth, still shedding the energy of its creation. That slow contraction is like the steady breath of time itself, invisible yet constant, a reminder that even giants evolve long after smaller worlds have gone silent. Jupiter endure, radiating warmth into the cold, outer dark. It is both ancient and alive, holding the memory of a younger solar system in its endless, glowing heart. Every flash of lightning within Jupiter's clouds is a spectacle of scale beyond anything on Earth. These bolts can be 3 times brighter and far more powerful than our strongest storms, illuminating the night side of the planet with pulses of white-blue fire. They ignite within deep water clouds, rising through layers of ammonia and hydrogen before bursting into brilliant light from orbit. These flashes appear like heartbeats in the dark, scattered across a world of endless storms. Each strike reveals the same simple truth that connects Jupiter to us, that light, no matter where it burns, is always a spark against darkness, a momentary reminder of energy, motion, and life. The poles of Jupiter are alive in ways we are only beginning to understand. Its magnetic poles shift slowly, almost imperceptibly, over centuries, changing not in chaos, but in rhythm, like the steady rise and fall of breath. This slow movement is called secular variation, a quiet heartbeat deep within the planet's core where metallic hydrogen churns and flows. As the currents inside shift, the magnetic field drifts, redrawing invisible lines of energy across millions of kilometers. It is a process of patience and balance, a cosmic inhalation and exhalation that reminds us that even the mightiest of worlds moves in quiet cycles, guided by forces that we can measure but never truly see. At Jupiter's south pole, a breathtaking sight unfolds a ring of cyclones, each one spinning like a colossal whirl of light, seen in infrared and ultraviolet. These storms shimmer like a slow, endless dance. 8 smaller vortices revolve around a single massive one at the center, forming a perfect pattern that has remained stable for years. The winds within these storms twist at hundreds of kilometers per hour, yet from afar, they appear calm, graceful, and symmetrical. Through Juno's eyes, the scene resembles a cosmic ballet, energy and stillness intertwined. light swirling upon darkness in an eternal, peaceful rhythm. Long ago, Jupiter's immense gravity may have shaped more than the orbits of its neighbors. It might have swallowed or captured entire worlds before they could fully form. In the chaotic early days of the solar system, Jupiter's size disrupted the field of debris that once surrounded the Sun. It drew in gas and dust that might have become another giant planet, claiming their material and halting their birth. Some scientists believe that fragments of those lost worlds still linger within Jupiter's core, mixed into its dense metallic heart. In this way, the planet may hold the fossils of unformed worlds, the remnants of paths that never came to be, preserved forever inside its swirling depths. Every planet in our solar system owes its stability to Jupiter's enormous pull. Its gravity acts like a cosmic anchor, keeping orbits steady and preventing the inner worlds from drifting too far or colliding too often. Without it, asteroids might roam freely through the inner regions, and planetary paths could wobble into chaos. Jupiter's presence maintains harmony, its motion shaping the invisible geometry of the solar system. Each revolution around the Sun is subtly influenced by its mass, its rhythm guiding the dance of worlds, the order we take for granted. The quiet clockwork of celestial motion exists because Jupiter stands guard beyond the asteroid belt, a silent architect of balance from hundreds of millions of kilometers away. Jupiter protects us still. Its immense gravity pulls in comets, redirects asteroids, and shields Earth from countless potential catastrophes. Each time it captures a stray object or absorbs an impact, it spares our fragile world from devastation. Though unseen and unheard, its influence reaches us every day in the steady rhythm of the seasons. In the calm of our skies, it is the great unseen guardian, ancient and patient, whose presence makes life possible, even from such distance. Jupiter reminds us that peace often exists because something vast and unseen chooses to hold the storm. Jupiter's storms form a tapestry that never sleeps. Beneath the glowing belts and zones are hidden tempests that rise and fade without ever breaking the surface. These storms can span thousands of kilometers, yet their movement is almost silent, a slow exhalation of energy from the planet's deep interior. Unlike hurricanes on Earth, they have no solid ground to end them. Instead, they merge and divide in eternal rhythm. Scientists believe that heat rising from Jupiter's core fuels this constant motion, turning its entire atmosphere into a living ocean of gas and light. To watch these storms is to glimpse motion itself, ancient, patient, and ceaseless. Jupiter's clouds are made mostly of ammonia crystals, forming thin, shimmering layers above darker regions of hydrogen and water vapor. These clouds stretch for thousands of kilometers, their patterns shaped by powerful winds that circle the planet faster than any storm on Earth. The colors we see, white, beige, red, and brown, come from trace chemicals reacting under ultraviolet light. High above, sunlight scatters softly across these layers, giving the planet its pearly glow. Each swirl and band is a frozen current of chemistry and heat, an ever-changing canvas painted by the physics of motion and time. Lightning on Jupiter is unlike anything we know. Buried deep within its thick clouds, massive electrical storms flash with power hundreds of times stronger than those on Earth. The bolts illuminate entire regions of the atmosphere, glowing through layers of ammonia and hydrogen like lanterns underwater. When the Juno spacecraft passed over these regions, it recorded bursts of radio waves that crackled across millions of kilometers. Some lightning strikes reach up through the clouds and light the night side of the planet, shimmering like soft pulses through the darkness. Each flash is a heartbeat of energy from within the storm's hidden heart. Not all of Jupiter's storms rage openly. Some remain hidden beneath the visible clouds, their presence detected only through heat signatures and radio waves. These deep storms may last for centuries, powered by slow convection rising from the metallic hydrogen below. Instruments aboard Juno have sensed their warmth, vast cells of rising gas that churn through thousands of kilometers of atmosphere. Unlike the Great Red Spot, which stands out in brilliant color, these storms are invisible, moving like ghosts through the lower layers. They remind us that most of Jupiter's life happens beneath the surface. In regions we can only feel through data and imagination, Jupiter's atmosphere is thick but layered, with each altitude hosting different winds and temperatures. The uppermost clouds race around the planet at 500 kilometers per hour. Butte, deep below, the motion slows, the heat rising through denser gases. Scientists think these differences in speed create waves that ripple upward, shaping the bands we see from space. It's a silent symphony: pressure, heat, and chemistry woven together in endless motion. The deeper one looks, the more Jupiter feels like a world without boundaries, not solid, not still, but alive in the slow rhythm of gas turning into light. The planet's storms create sounds too faint for human ears: low-frequency rumblings, electromagnetic pulses, and soft radio waves that echo through the magnetosphere. Probes like Voyager and Juno have captured these signals, translating them into eerie audio. When played back, Jupiter's storms sound like a chorus of wind and electricity, rising and falling in ghostly tones. These sounds are real vibrations of plasma and energy, the literal voice of a planet speaking in frequencies older than life itself. To listen to them is to hear the deep breath of a world made entirely of storm. Some storms on Jupiter form temporary ovals that last for decades before fading into the larger cloud bands. These white ovals are smaller cousins of the Great Red Spot, and they drift slowly around the planet, merging or vanishing without warning. Their births are quiet, small disturbances in the jet streams that grow into circular tempests. From Earth, they appear as tiny white scars on the planet's surface. But up close, each one is a vortex the size of a continent. Together, they trace the history of Jupiter's endless turbulence, writing stories in motion across its vast, restless sky. Ammonia snow may fall inside Jupiter's atmosphere, melting into rain as it descends through warmer layers before evaporating again near the lower depths. Scientists believe this process, called a snow cycle, happens continuously, forming thin hazes and icy streaks within the clouds. In some regions, ammonia combines with water to form slushy hailstones, the mushballs, detected by Juno's sensors. These mushballs may carry heat and energy downward, helping mix the atmosphere in ways still not fully understood. It's a strange kind of weather, a cycle without ground. Snow that never lands, rain that never truly falls. Jupiter's heat comes not just from the sun, but from its own heart. As the planet slowly contracts under gravity, it releases energy, a process that has lasted for billions of years. This internal heat radiates upward, feeding the motion of clouds and storms. Without it, the planet would be cold and still. With it, the atmosphere churns endlessly. This hidden warmth is why Jupiter glows faintly in infrared, why its belts and zones shimmer with life. It's the same energy that keeps stars burning, gravity turning inward. and light quietly escaping outward. At the edges of Jupiter's immense storms, subtle waves ripple outward, shaping the flow of its atmosphere. These waves carry energy across the planet, linking storms thousands of kilometers apart. Some scientists think they act like a heartbeat for the atmosphere, pulsing in regular intervals that keep the planet's chaotic motion balanced. It's as though Jupiter's storms breathe together, each one echoing the rhythm of the others. Beneath all that violence and power lies an unexpected serenity, a world that moves in harmony even within its endless turbulence. When viewed through infrared telescopes, Jupiter transforms into a glowing world of heat. The dark bands fade, replaced by glowing filaments where warmth escapes from below. Each color in these images marks a temperature: bright yellow for heat, deep red for cold. To the human eye, Jupiter looks solid and calm, but in infrared it becomes transparent, revealing its living layers. The sight is almost spiritual, a gas giant, seen not in reflected light, but in its own glow. The energy of its creation still radiating softly into the cosmic dark. Every wavelength of light tells a different story about Jupiter. In ultraviolet, we see the power of its auroras, invisible light, its swirling clouds. In infrared, the hidden heat beneath. Together, they form a portrait of a world too complex for one color to describe. Spacecraft like Juno and Hubble combine these wavelengths to build full-spectrum maps, a mosaics of energy that reveal how light and matter intertwine. To study Jupiter this way is to see the invisible heartbeat of a planet pulsing across the electromagnetic sea. Through radio telescopes, scientists have detected strange bursts of sound from Jupiter's magnetosphere. Some are sharp and rhythmic, others rise in soft whistles as charged particles spiral through magnetic fields. These emissions tell us where electrons move, how lightning flashes, and how moons like Io feed the planet's magnetism. It is a kind of language written in electricity, the voice of plasma speaking through the silence of space. When converted to audio, it becomes hauntingly beautiful, like a chorus echoing through an endless cathedral of light. The planet's glow changes with every sunrise on Earth. Its light takes over 40 minutes to reach us, carrying the reflection of storms that ended before humans existed. Every photon that strikes our eyes tonight left Jupiter long ago, crossing hundreds of millions of kilometers through the Black Sea between worlds. When we look up at that golden star, we are seeing the past, a still image of motion that never stops. In its steady shimmer lies both distance and connection, a reminder that even the quietest light can bridge impossible space. Sometimes, Jupiter vanishes behind the moon during a rare alignment. For a brief moment, it disappears, a giant hidden by a small and fragile world. When it re-emerges, glowing against the dark sky, it feels almost alive. Astronomers call this an occultation, but to the sleepy mind, it feels like a breath, a slow blink of the cosmos. These celestial alignments remind us how vast yet delicate our perspective is, how easily a whole planet can slip behind a shadow. Watching Jupiter return is like watching thought itself emerge from silence. Each of Jupiter's colors tells us about motion, chemistry, and time. The pale zones are high, cold clouds of ammonia ice. The darker belts are warm, lower layers of sinking gas. Over months and years, these bands shift and breathe, their borders blurring, their hues changing. Yet through all this transformation, Jupiter never loses its calm shape. It remains balanced. neither chaos nor order, just movement that continues without end. That endlessness is its beauty, not a storm that destroys, but one that endures. Even now, new missions are being planned to follow Juno's path. Some will carry infrared spectrometers, others plasma detectors or ice-penetrating radar. Each one will look deeper into the planet's mysteries, into its storms, its heat, its magnetic heart. But the closer we look, the more Jupiter becomes not a place, but an experience. It is both motion and stillness, both chaos and calm. Every discovery only deepens the mystery, reminding us that knowledge does not end wonder, it expands it. Jupiter glows softly in the background of human history. When early civilizations looked up, they gave it names of gods. When telescopes were built, it revealed its storms. When probes were launched, it shared its secrets. Yet through every age, its light has meant the same thing: constancy. The planet has been there for every rise and fall, every dawn and every night. To watch it now is to stand in the same light our ancestors saw, a light that has guided minds and dreams for millennia. If the solar system were a symphony, Jupiter would be its deep, resonant note, the tone that grounds all others. Its gravity shapes the music of orbits. Its storms add rhythm. Its magnetic field hums like a bass line through the cosmic score. Every smaller world moves in response to its mass, dancing within the soundless harmony of its pull. The melody of space begins and ends with it, a song that has no beginning, no end, only motion within stillness. And finally, Jupiter's greatest gift is perspective. It shows us that even in chaos, there can be grace. Even in power, there can be calm. Its storms are endless, yet they form patterns of balance. Its light is fierce, yet steady. To watch it is to feel time slow, to realize that peace does not mean stillness, it means continuity. In the vast dark sea of space, Jupiter reminds us that motion itself can be serene, that even the wildest forces can become a lullaby. In the end, Jupiter is not just a planet, it is a rhythm, a slow pulse of motion and gravity that has been breathing through the solar system since the beginning of time. It does not speak, yet its presence holds every orbit in place, its pull shaping the paths of moons, asteroids, and worlds. When you look at it from afar, glowing softly against the dark, it feels less like a place and more like a heartbeat that the universe forgot to silence. We have traveled through its storms, the vast belts of clouds that never stop turning, the great red spot that has outlived entire civilizations, and the invisible layers where gas becomes liquid and liquid turns to metal. We have seen the lightning that flashes brighter than the sun, the auroras that burn at the poles, the deep heat that hums inside, all of it moving slowly, endlessly, perfectly balanced in silence. Around it drift the Galilean moons, each one its own world: fiery Io, frozen Europa, magnetic Ganymede, and ancient Callisto. Together they circle like memories around a dream, each whispering its own story of fire, ice, and time. Beneath their surfaces are oceans, volcanoes, magnetic tides, and frozen plains that glow under distant light. And through it all, Jupiter watches not as a god of thunder anymore, but as a guardian of stillness, holding chaos in quiet order. Every probe we've sent pioneer, Voyager, Galileo, Juno has passed close enough to feel its invisible pull, to taste its radiation, to listen to the low hum of its storms. They have shown us a world so vast it bends the imagination, a planet that could swallow 1,000 Earths, yet still moves with the grace of a whisper. Even now, spacecraft glide above its poles, recording the soft glow of its cyclones, the shimmer of plasma around its rings. They orbit in silence, their metal shells warmed by the reflected light of the giant they study. To scientists, Jupiter is data mass, pressure, magnetism, heat, but to the dreaming mind, it is something else entirely. It is calm, made visible. It is the proof that power and peace can coexist. Every storm there is an act of balance. Every aurora, a quiet song. It reminds us that chaos is not destruction, it is movement seeking stillness. Just as thoughts do before sleep, when the night is clear and Jupiter rises above the horizon, it looks unchanged from the way our ancestors saw it thousands of years ago. The same light, the same motion, the same presence. That constancy carries a message older than words, that the universe does not rush. It turns slowly, endlessly, with patience so deep that even time feels small within it. We are part of that same turning, every breath synchronized with the movement of stars and storms, and somewhere in that vastness, on a tiny world orbiting a medium star, we look up, we watch a distant planet, and find ourselves reflected there in its storms, in its quiet, in its endurance. Jupiter reminds us that strength does not need to roar, and that silence can hold the weight of creation. It teaches us that calm is not the absence of motion, but motion without fear. As you listen now, let your breath follow Jupiter's rhythm slow, deep, unhurried. Feel how even the smallest thought begins to dissolve, how the noise of the day fades like a storm passing beneath the clouds. You are floating above its vast atmosphere now, watching the belts drift beneath you, the auroras glowing far below like veins of light. The planet turns once every 10 hours, but up here, it feels timeless. There is no beginning or end, only the quiet movement of color, heat, and gravity. Let that silence carry you. Let it draw you into the same stillness that keeps Jupiter turning a calm so complete that even storms become gentle. The universe does not hurry. It only moves. It only breathes. So tonight, as you drift towards sleep, imagine that great planet watching over you from millions of miles away, its light steady, its storms eternal, its voice a whisper of warmth through the dark. You are safe beneath its gaze. You are small, but you belong to something vast, and in that endless motion, everything is at peace. Let your breath slow. Let your mind grow quiet. Good night.